Yeah, so I'm a material scientist by training, and you may wonder what that is. So material science is a combination of physics, chemistry, and mechanical engineering. And if I explain that to a general audience, then I often say material science is about you have to make it out of something. So if you live in the Stone Age, then the materials that you had available were stone, wood, string, clay, some glue maybe, and that defined what you could do. Before I came to the United States, I lived in Austria and in Germany, and my favorite spare time activities are skiing and horseback riding, traveling, mountaineering. I also love to cook, and I also enjoy exploring wine and things like that. So most people have a story how they ended up in their job where they are now. And in my case, um, my career choice was mostly driven by curiosity. So I'm a very curious person, and I always want to understand how things work and lift the curtain, so to speak. And you might not be surprised if I tell you that the first book that I read from cover to cover was the children's encyclopedia from A to Z. So no Mickey Mouse books or little short novels. I was interested in the encyclopedia. And then everybody has these key moments. And for me, the key moment to study material science was when we were 15 years old and did the excursion with high school. We visited a university in a small town in Austria, which is called the University of Leoben. And we had a little introduction class in material science by the professor who was at that time the elected regent or president of the university. And he said a lot of things that were interesting. First of all, material science was interesting and how you understand why things have strengths and what you can do to improve it. But he also said we have 1,500 students, 200 faculty, and that ratio is basically unknown for any other public university. And this university has the lowest rate of people with a degree who end up being unemployed. And all these things together encouraged me with 15 years old to study material science once I had my high school degree. After I graduated with my master's degree in material science from the University of Leoben, I went to Germany to the Fraunhofer Institute for Mechanics of Materials and got a PhD there. And I studied the sintering of ceramics and developed a computer program to predict how the ceramic will shrink during the sintering process. Sintering is just a fancy word for firing the clay or whatever other kind of ceramic you use. And as I was ready to graduate there, I attended a scientific conference and I started to talk with a guy from Sandia National Labs about what I do and my work. And yeah, based on that conversation, a couple of months later, we had another phone call and we talked about doing a postdoc at Sandia National Labs. So once I graduated with a PhD, I moved with my wife to Albuquerque, and I worked for 2 years as a postdoc, continuing my sintering research there in Albuquerque. So when I was about to graduate with my master's from the University of Leoben, I had a conversation with my master's advisor and asked him if I should do a PhD. And then he said, take out a piece of paper and make a list of the pros and cons and put it away and open it up again once you're done with your PhD. And I bet with you that none of the things that you wrote down in hindsight really mattered, because it's very hard to imagine what will matter 3-4 years down the road. So from a career perspective, I would say go for what you're passionate and what you motivates you, and don't overcalculate every move that you want to make to get to a certain place, because life is too variable to really plan too much. So during the last 15 or 20 years, when I've been working first as a true material scientist and now later more as a medical device engineer, my day-to-day work has dramatically changed. So when I worked at Sandia National Labs or the early days at Medtronic, I would spend 8 hours a day doing finite element simulation, so doing very hardcore computer calculations using very, very fancy programs. And I was often asked, so what fascinates you about doing this kind of work? And I said, you know, that's like computer games for grown-up people. And I loved it. To tinker and try to figure out why it doesn't work and what you had to do to make it run. And I could really zone away and be there, just me and the computer program. And then as your experience grows and your knowledge base widens, you get more and more pulled into solving more general problems and not so deep problems. My job has mostly become listening to problems, listening to people, trying to associate the problems with things that you know, trying to find related knowledge in the literature or on the web, and then building your story together, how things happen, why this is a problem or what we should do, and then communicate it back to the project team to influence the direction that the project goes. So I would say 90% of my day is now related to communication or consuming information or spreading information. So I got pulled into starting an internal innovation campaign, how Medtronic knowledge can be tapped to help with the COVID crisis. And very quickly, some of my colleagues who have 3D printers in the labs participated in the crowd production process for frames for face shields that were then delivered to hospitals. Through that same kind of connection, I also got involved in 2 external projects with 2 groups that at that time were developing emergency ventilators, because it looked like ventilators would be the thing that is most needed and the hardest to get to save lives. So one team was from the University of Minnesota, which developed a really, really simple ventilator with 2 controls and a couple of mechanical valves, and that was basically it. And within 3 weeks, the prototype was developed, and with another 3 weeks or so, the FDA has granted this emergency use authorization so that the equipment could be used on a human. The other project was a little bit slower, but it was a lot more sophisticated concept with electronics and controls, and would be fairly close to a true ventilator. And the project was initiated and run out of NASA's Jet Propulsion Labs in Pasadena. And on both teams, I served as an external advisor for medical device engineering. Try to understand what motivates you and not necessarily only what interests you, because motivations are a lot more foundational than interests. Interests change over time, but what really motivates you is, for most people, pretty steady throughout their lives. And you know, a career can be 30, 40 years. So you want to do something that can keep you motivated for many, many years.